Okay, so now we're on page 4 of our Chapter 6 class examples. Suppose a normal model describes the fuel efficiency of cars currently registered in your state. The mean is 24 miles per gallon with a standard deviation of 6 miles per gallon. Sketch the normal model. So this is just like the last two examples we completed. So you should be able to do this. Notice it's got a title, we've got units. It's a normal model centered at 24 with a standard deviation of 6. And here's the empirical rule drawn out. Next page, page 5. Suppose a normal model describes the fuel efficiency of cars currently registered in your state. The mean is 24 miles per gallon and with a standard deviation of 6 miles per gallon. So this is exactly the same as the problem we just did. Okay, but now it asks us what percent of all cars get less than 15 miles per gallon. So you'll start with that same sketch of a normal model. It's centered at 24, it's got a standard deviation of 6, and I'm interested in the percent of cars that get less than 15 miles per gallon. So 15 is between 12 and 18, and less than would be to the left. So we are interested in the area underneath the curve to the left of 15. So in our calculators, what we would do is we would turn it on. You're going to hit the second button and then the variables button, and above that it says distribution, and you'll get your list. And then you want to choose normal CDF, not PDF, C as in Charlie. Actually, it's C as in cumulative, and it stands for the normal cumulative distribution function. And you're going to hit enter. Your lower bound is technically negative infinity. There should be something in there. You can put negative 999, whatever. Just a very small negative number. Then our upper bound is going to be our right bound, which is that 15 that was given to us in the problem. And then our mean is the 24, and the standard deviation is 6. Hit paste, hit enter, and we get 0.066. So on our diagram, we are going to label the area that's shaded as 0.0668. Okay, and then what we would answer in this question is about 6.7% of all cars get less than 15 miles per gallon. Okay, so the keystrokes that I used for this problem: second, distribution, which is above your variables key, normal CDF, lower bound, upper bound, mu and sigma. Your sentence would be about 6.7% of all cars get less than 15 miles per gallon. Page 6. It's the same scenario, only now we are interested in what percent of cars get between 20 and 30 miles per gallon. So we start with that same illustration, but now our shading is going to be different. 20 is somewhere between 18 and 24, so our 20 is going to be about here. 30 happens to be one standard deviation above the mean, so that's already labeled for us. We are interested in this percentage. So again, you'll use your normal cumulative distribution function in your calculator. So hit second, variables, which says distribution on top, go down to normal CDF for cumulative distribution function. Now your lower bound is going to be that 20. The upper bound is going to be the 30. And our mu is still 24. Our sigma is still 6. We're going to hit paste, enter, and we get 0.5888, etc. So then we're going to label the shaded portion as 0.5888. 0.885, or you can make that a 9, whatever. And your sentence that would go with this is about 58.9% of all cars get between 20 and 30 miles per gallon. Your completed sentence, about 58.9% of all cars get between 20 and 30 miles per gallon. Next question starts with the same scenario, but now we're interested in what percent of cars get more than 40 miles per gallon. So we're going to start with that same illustration. 40 is going to be somewhere in here. We are interested in more than 40. So we're going to shade this portion of the normal curve. And this time we're going to use that same function in our calculator, second, variables, which will give you the distribution menu, and then you want to choose normal CDF for cumulative distribution function. Your lower bound is now the 40. Your upper bound, you can just enter a bunch of 9s. Just do a bunch of 9s. Our mu is still 24. Our sigma is still 6. Hit paste, hit enter, and it gives us 0.0038. So if we move our decimal space over 2, only about 0.38% of cars get more than 40 miles per gallon. Okay, so your sentence there, about 0.38% of cars get more than 40 miles per gallon. Moving on to question page 8, same scenario again, only now the question says, describe the fuel efficiency of the worst 20% of all cars. So you're not going to know exactly where to shade this until you push the buttons in your calculator, but I'm going to show you. It winds up being about here. And the area underneath this curve is 0.2, or 20%. In this case, now we're going backwards. We have the percent, we have the area under the curve of 0.2. So we need to undo this. So we're going to use the inverse normal function on your calculator. So in this case, it's going to be second variables, which gives you your distribution menu. And now you're going to go down to inverse norm. And it asks you for the area. The area under the curve is 0.2. Our mu was given to us as 24. Our standard deviation, or our sigma, is 6. And then we paste, and we hit enter. And what that tells us is that is actually at 18.95. So that's how I knew to draw the line right here, is this is at 18.95. Okay? So here's the keystrokes, second distribution, inverse norm, 0.2, 24, and 6. According to the normal model, the worst 20% of cars have fuel efficiency less than about 18.95 miles per gallon. Okay, page 9, same scenario. Start with the same illustration, but this time it asks us what gas mileage represents the third quartile. So quartiles are 25% each. The third quartile, this tells us we're looking at 75%. Okay? So again, we're going to be doing an inverse norm. So we're going to take our calculators, second distribution, inverse norm, because we're given the percent, which is 0.75. We're centered at 24 with a standard deviation of 6. Paste, enter, it gives us 28.0469. So we're going to draw that in. I'm just going to round to 28.05. We are talking about this 75% of our cars. So we label that as 0.75. And the third quartile of the distribution for fuel efficiency is about 28.05 miles per gallon. Next question. Describe the gas mileage of the most efficient 5% of all cars. So now we're interested in this little piece up here, but our calculators don't know how to do that. So what we have to look at is 95% from the left will also give us 5% from the right. Okay, because it's 100% under the curve. So again, we're going to use our inverse norm. So second distribution, go down to inverse norm. We have 0.95 centered at 24 with a standard deviation of 6. And we get 33.869. So I'm going to draw that in here. I'm going to round it to 33.87. We are worried about the top 5%. So this is 0.05. Okay, make yourself a note. That is inverse norm of 0.95. Okay, and then your 24 and your 6. And the most efficient 5% of all cars get better than 33.87 miles per gallon. And then our last question about this same scenario is, what gas mileage would you consider unusual and why? So that depends on what you consider unusual. We generally talk about either 2 or 3 standard deviations from the mean. So if 2 standard deviations from the mean is considered unusual, then above 36 miles per gallon or below 12 miles per gallon is unusual. And I would actually write that out in my answer. Or you could also write, if you were going to be more conservative, if plus or minus 3 standard deviations is considered unusual, or if 3 standard deviations from the mean is considered unusual, then above 42 miles per gallon or below 6 miles per gallon is unusual.